All right, so week 4, we are going to talk about querying from multiple tables. And, that's basically the layman's term way of saying we're going to work on joins. There's a bunch of different type of joins. I think that the PowerPoint walks you through them pretty good, but I thought what might be better for us this week is actually just to kind of go through a bunch of examples. And so what we're going to do is we're going to go through some of the exercises. We're just going to kind of jump right in. We're going to do some of the exercises here together, talk about them, and then maybe do a couple spin-offs on some of them. So anyways, let's just jump right in. So what I'm going to do is I just have the week 4 exercises up, and we're just going to kind of start. And I know they kind of give you a lot of this, but we're going to kind of start from scratch, and I'll kind of query it as if we were, looking to do something real life with it. So naturally, like always, we start with Sequila here. And let's see. I'm missing. There we go. Okay. So there's Sequila. We're looking good. Let me make sure I get this the way we want it here real quick. There we go. All right. So we use Sequila. So this first question, it just wants you to kind of fill in the blanks, but ultimately what it's saying is we want to get first name, last name, address, city. And we can kind of make some inferences based on the query here, that we only want it where the district is California. So anyways, basically we want to get a list of our customers that are in California, and we want their addresses. Maybe we're going to kind of prepare a mailer, right? Like where they send out mail to all of our customers saying like, hey, we're having a 50% off deal or something. So that's kind of the scenario we'll play it as. So anyways, I kind of always like to just kind of layer on data, especially when it comes to joins. I like to layer on data. And it's really important because depending on what kind of question we're trying to answer will change what type of join we perform. So anyways, a lot of people may always kind of start with the columns. I actually don't prefer that way. I usually kind of say like, hey, give me everything. And then I kind of whittle it down after that, because then I can kind of see what's going on. So the first thing we're going to do, and like I said, I like to always kind of layer my stuff on. We're going to select from our first table. So in this case, I'm just going to select from customer. I kind of like doing this because then you can kind of like see what's in there and so on and so forth. Now, I assume that a lot of us are probably still maybe not completely familiar with our database. So what I always like to do is say like, okay, we are trying to get our customers' information plus their address information. So, I start that basic where I say, hey, here's our customer table. Great. We can kind of see what's in here. And then I'll look and say, okay, let's find the address table. And I'll literally just select everything from both of them. If they're huge, which we don't worry about in this class, I'll limit the response with, can narrow it down so it only includes like the first 10 rows or something like that, just to save on processing. But anyways, we don't worry about it in this class. So now that I have both of these where I can kind of look at them, kind of the key is we look for the common denominator, because what we need is we need a way to get from customer to address. So we kind of look for a path to get there. And so we can see here in address, we have this address ID, and not much else. We just have like address information after that. So let's go back to customer. If we're looking here, you'll notice, oh, hey, here's this address ID. So that is, in this case, address ID is our foreign key. It's the key that doesn't belong in the customer table, right? It's not a customer ID, it's an address ID. It's foreign to this, but it just exists there to link something. And so that's kind of our key combination. So we're going to go from customer to address based on that key of address ID, because this address ID, which is the foreign key here, will link to the addresses table address ID, which is the primary key. And that's the good database design, is that a foreign key connects to the primary key of some foreign table. So anyways, I'm just going to kind of build off this. Now, one thing that maybe we haven't talked about is table aliases. So table aliases are where we can kind of give a table a shortcut. Because we could do this, right? We could say, inner join address and and then keep going where we say on whatever. And I'm actually going to do it this way first, just so we can see it. And then we'll do the shortcut version. So I'm going to say customer dot, and just like we talked about, we want to connect on that address ID from the customer table where it's equal to the address ID from the address table. So that's why you can see here I do customer dot address ID is equal to address dot address ID. Now, I don't know if any of you guys saw the quick bite videos that were in the announcement, but I want to pause here. So we'll run this real quick because what this will do is it'll give us basically every customer and their address. But I want to kind of pause here and kind of do a couple queries to kind of show you exactly what the database is doing. So essentially what the database is doing, and this is called ANSI 92 syntax. You may see it in the book at some point. This is ANSI 92 syntax with the inner join particularly. There's an old standard called ANSI 89, and it looks more like this. So we're going to basically write the same query, but instead of doing a join, we're going to just put a comma. And I'm going to do it just like this. And just for the sake of kind of limiting it, we're going to pick on a specific customer, and I'm just going to pick on the first one, Mary Smith. So customer ID 1. Right. So basically, you'll notice the difference here. There's no on clause in this one, and they're just separated by a comma. But watch what happens, right? So when I run this, you'll notice that we get many results. We're duplicating her, not what we expected, right? And essentially what we're doing here is we are joining the two tables, but completely agnostic to what any condition, meaning that we're doing what's called a cross join. And what a cross join is it's simply multiplying. It says, okay, I'm going to match every record from the customer table to every record in the address table. So if I were to take out this where clause, we'll get every address, every customer with every address, right? So you can see over here, we have 47 Mysequila Drive. We go through every customer and so on and so forth. And we get a ton of records. In fact, we could count how many there are. And if we do it right, so we have 361,800 records. And what that is it's just taking customer and multiplying it by address. Just like if we had two pairs of die, or two die, a set of dice, if we wanted to know every possible combination, we would just take die one times die two, which ends up being every possible combination between the two. And that's essentially what we're doing, but we're doing it between two tables. So in this case, we get every customer and every address. But what we do is naturally we don't want that because that would be just garbage data, right? If this is the way databases worked all the time, you would get literally everyone's spam mail or whatever. We would see everyone's Facebook post, and it would just be a mess. It's just not, there wouldn't be a reason for it. So what we want to do is we want to limit it, just like we did up here where we said, hey, look, we only want to join these up where we have matches, right? And so what we can do is we can say, okay, where customer.address ID is equal to address.address ID, right? Because if we were looking through this list, we could probably find whoever's real one. So for example, this is address ID 1, 47 Mysequila Drive. And we can see that this actually does belong to Myquillier. So the first record in this is right, but everything after is wrong up until we probably get to the next address. which we could probably go through here and look if we really wanted to. In fact, here it is, address ID 2, right there where it starts, and we would have to find address ID 2 in this one, which I don't know if we get there or not before we hit the row limit. So anyways, naturally we want to find it. We want to filter out all the non-matches, right? Because we know this one's wrong. Address ID 2 does not equal address ID 586. So we want to kick it out. So that's essentially what's happening when we join this data, is we get it to where, we're connecting two tables. And I like to think about it this way. We're expanding horizontally. We're adding columns to this. But when we add columns, we have to make sure that we do it, in a smart way, because no matter what, there's a possibility of duplicating some data on either side, right? You'll hear things like one-to-many relationships. In this case, because customer ID holds the address ID, technically, there can only be one-to-one because address ID is the primary key. Now, there could be multiple customers with the same address, right? We could have, Mary Smith have address ID 5 and Patricia Johnson have address ID 5 and both connect to 1913 Hanoi Way, right? That's possible. If it's designed that way, if you have multiple family members that have an account that all live at the same address, that's by design. So whenever you do joins, you have to kind of think like, what's the relationship? Is it a one-to-many or many-to-one? And think about it, because depending on what you do, you may duplicate some data, which, like in the case of, hey, multiple customers all live at the same address, that's fine. But, maybe you're working with revenue. You don't want to duplicate revenue, something that's not real, so to speak. So anyways, that's essentially what's happening. This is the ANSI 89 version, where you can see that basically it does more work, because it creates a full cross join. The Cartesian product, you'll see that word come up too, which is, like we talked about, customer times address. So, if we were to do a pure count of the rows, it would be how many records are in customer times how many records are in address. And that's our total records. And then, so ANSI 89 does that multiplication. It stores all that in memory. And then after the fact, it has to go and filter it just like it would any other where clause, and kind of go through and find the ones that match. So the difference is between ANSI 89 and ANSI 92 is that we can provide this on clause, which basically does it as it goes. So it's just a little bit more efficient and a little bit different format, really, a little bit different syntax. Now, I promised you I'd show you a little bit of a shortcut. So, using the same ANSI 92 syntax, like I said, we're basically only going to use ANSI 92 syntax. I'm going to change this, and I'm going to say, okay, customer C. So I'm going to give this a table alias is what it's called, basically a nickname. So now, from now on, instead of having to do customer.address ID, we can refer to it as C. So then I'm going to say inner join address, and we're going to call address A on, C.address ID equal to A.address ID. So really, it's just a matter of saving some keystrokes, saving some words on the screen. They perform essentially the same thing, except for we give it just like a little shortcut, and it's called a table alias. So anyways, that's basic joins. Now, we're going to get a little bit into the left, inner, right, and all that kind of stuff, maybe here in a minute. So we're going to put that on the back burner. Let's finish question 1, which is we want to get all of our customers, their address, and the city that they're in. So if we look at our data set now, you can see that we have, all of our data here at our disposal. And no matter what, like, even if you select different things, you always have all the data behind the scenes working. Because that's why when we talked about the select list, the select statement, this runs first. So all the data is there. It's not until the very last step that it actually says, oh, this is what you want to see. So all of our data is there. So that's kind of what we're seeing right now, is everything that we kind of have here. So if we look through here, you'll notice that we don't have a city column, and that's because there's a city table. So just like I did before, I'm going to come up here and just say, hey, show me everything from city. And let's see what we can match on. You'll notice that we have a city ID, the city name, a country ID, and then just the time it was last updated. If we come back here, I'm going to move this one up. Looks like we left it behind somewhere. Take a look at address again. Because remember, we're looking at this pathway, right? So, oh, hey, look, here's a city ID. So boom, now we can do the same thing where we can say, okay, we've gone from customer to address. I'm going to delete this one since it's the long form. We've gone from customer to address. We've got those tied up. Now what we want to do is we want to take what we've already done and tie it to city. So the way that these joins work is that basically once you form a join, so from right here, this thing kind of acts as a singular table. I mean, it still knows the aliases and the columns, but it kind of acts as its own result set now. So it's very much in order of operation. So now we say, okay, yeah, we want to join on city. I'm just going to call that, we'll call it CT for city. And we'll say on a.address ID, right? Because we want to go from address. Address has city ID. But instead of address ID, we want to go from the city ID in address. So that's where the A dot comes from. So city ID is equal to CT dot city ID. Now, one thing that's easy to kind of, get confused, basically on any join, you just want to make sure what you're joining on. Most of the time, if everything's designed properly, you should join on the same kind of name of the column. They may be different depending on what they do, but the same context. In this case, in Sequila, almost everything is named exactly the same. And so you'll just want to make sure that you go from the table that you already have to a table that you want to get to. I kind of think of it like, you're building this connection. You're roping between what you already have to something that's out there. In this case, we're going from address, which we've already incorporated, to city. So now we can run this. And now you'll notice that we get all the way over here. You can kind of check, hey, city ID 463, city ID 463, address ID 5, address ID 5. So you can kind of see how it's connecting the dots here. And now we're going to actually do the last little bit here where we only want it where this, and in this case, actually, it looks like they only want it where the district is in California. And the district is from address. Whoops, we need the where clause. We'll say where a dot district is equal to California. And you can kind of see how I layered that on. You can run it along the way, so kind of make sure you're kind of building on your rows, your columns here as you kind of go along. And so there we go. We're only seeing California-based stuff now, District California. So now as my last step, I'm going to change this to be what we want. So we want the customer first name, customer last name, the address. And that's why I kind of like this, because you kind of see it here as you go. We want the address, and then we want the city that the address is in. And there we go. So that's number one on the exercise. Does anyone have any questions up to that point? Okay, perfect. We'll keep going. All right. So on question one, you'll notice that it's kind of a little different. Basically, it wants you to fill the gaps here. So, you just put like, oh, one is A and two, in this case would be CT dot city ID, something like that. All right. Question two. Let's take a look here. All right. It says write a query. This is a good one. Write a query that returns the title of every film in which an actor with the first name John appeared. right? So basically we want to see all the films that has a John within the film. And this is a good example. I mean, we've all kind of been there, like maybe we're on IMDb and we just search for John, right? Now it would probably pull up movies, but maybe there's like a way you can say, hey, I'm looking for an actor or films that have John in it, common scenario. So that's essentially what happens in the background on those. Is it actually runs a query to pull that information. So, anyways, let's take a look. So let's first select everything, and like I said, we're looking for films, right? So let's start there. Let's start a film. So inside film here, you can see a bunch of different stuff. We got the title, description, the release year. We have a language ID, original language, duration, rental rate. How much does it cost to rent the movie? How much does it cost to replace? All that kind of fun stuff. But you'll notice in here, we don't have any actors, right? And that makes sense because how many actors are in a film? I mean, I'm sure that there's probably a film out there somewhere that has 0 actors, and I'm sure that there's a film out there that has, thousands of actors. And so, anyways, it would be hard to incorporate a structure that could handle that varying degree of variety. So you'll notice that we don't have any actor here. So the question is well, and let's flip the coin here a little bit. An actor can be in more than one film. So what we end up with is this many-to-many relationship where a film can have multiple actors and an actor can have multiple films. And so many-to-many relationships are bad in the long run. So we don't do them. But what we do is we can kind of finagle it, and we can build a one-to-many relationship one direction and a one-to-many relationship the other direction. But what it needs is this middle table to kind of serve as this liaison between the two. And if we look through our list of tables, you'll notice that we have exactly that. We have a film actor. So we have an actor table, we have a film table, and then we have this film actor table. So let's take a look. First, let's select everything from actor. Sorry, I'm getting ahead of myself here. You'll notice again, no film stuff, pretty basic, just basically their first and last name. But if we take a look at film actor, we will see an actor and a film. And so this is kind of like our where it connects. So film has a one-to-many relationship with film actor. And let's kind of just draw this out here. So film has a one-to-many relationship. We'll do it like this with film underscore actor. And then actor has a one-to-many relationship with film actor. So you can kind of see how this works, where basically what we end up with, if you ignore this, pretend this doesn't exist for a minute, you can see we have this many-to-many relationship going on here, where essentially, many actors can be in many films. But if we put this little in-between guy in there, all of a sudden we can incorporate that. And that's essentially what we do. So for example, let's find all the films with John. So we're going to select everything again from film. We're going to call that F, right? So let's start there, just like our previous one. Like I said, I always like to kind of build. And then let's layer in film actor, because we can't go straight to actor, right? There's just no way to do it. So we're going to do, again, an inner join. So we're going to go from film to film actor. And what are we going to do it on? Well, we're going to do it on f.filmid is equal to fa.filmid. The film ID from film should equal the film ID from film actor. Just makes sense. So here we go. We have all of our films and all of our film actor stuff. And you'll notice that it really didn't add much besides this actor ID. So let's go ahead and now join to our actor table. And again, now we're going to go from film actor ID to the actor ID and actor. Boom, there we go. So now we should have everything joined up. I'm going to add a quick order here so we can kind of see this. We're going to say order by f.film ID. So we can kind of see like everything going on here. So you'll see that Academy Dinosaur has multiple records, and that's because it has multiple actors. Right? So now we can see all the actors in here. So that's exactly what we wanted. So now what we're going to do is we're just going to filter this to say, hey, we only want it where actors' names is equal to John. But I guess it helps if I don't hit the delete key. There we go. So now we have all of our films where the actor is equal to John. And we can kind of check this. And really, we only have one actor, John Suvari. And you can see that he's just in a ton of films. All right, pretty neat. All right, so there is number 2. All right, so question 3. This one is probably the one that throws people. I guess I'll pause there. Does anyone have any questions? That one is a lot of the same one, so I'm going to assume we're good. So question 3, this one is a little bit different. So this is the one that I always like to kind of do because it is a little different. It's kind of a concept that you wouldn't think would ever be useful or ever think through, but it's super useful and you have to do it all the time. So anyways, it says construct a query that returns all addresses that are in the same city, right? So basically we just want to see every address that's in the same city. And it says you will need to join the address table to itself, and each row should include 2 different addresses. So basically we just want to see all the addresses that are in the same city, and yeah, each row 2 different addresses. So basically we're pairing up. So this one took me a while to kind of come up with a scenario for, but then I found the perfect one. So what we're going to do is we're pretending that we're going to do a Secret Santa, right? But in order to do a Secret Santa, we need to pair up different addresses with each other, but we want to keep it within the same city, right? Like we say, hey, we're doing this community deal where we paired, 2 families up for a Secret Santa, right? We're pretending it's a perfect world. Everyone wants to participate. So anyways, we do the Secret Santa thing. So that's kind of the objective, is we want to randomly, or not randomly, but we want to see every possible combination of 2 households, right? Because then we can kind of pick them out at random. So we want to see every possible combination of 2 addresses that are in the same city. And you probably already saw it, but it said, hey, you're going to have to do a join to the address table back to itself. So we're going to start there. We're going to select everything from address. And anyways, whenever we join something to itself, it's called a self join. So this one is, it's called a self join because it goes back to itself. And that's just what it's called. You do it the same way as any other join. So the only difference here is that whenever you do a self join, you have to use an alias, because otherwise it would be ambiguous. So we're going to call this one A1. And then what we're going to do is we're going to interjoin address A2. So kind of funky. And then we have city ID, and we know we want them to both be in the same city. So I'm going to do A1.cityID is equal to A2.cityID. And you'll notice that we have an error here somewhere, and that's because I'm missing onward. There we go. So anyways, now we're left with this. And what I'm going to do is I'm going to sort this. I'm going to say order by city ID and then address A1 dot address ID. I guess we need to do this too, or else it complain. So there we go. You can see here now that we're looking at specific cities. And some of these may actually only have one. So let's see if we can find one that has two addresses in it. Right here. So 42. City ID 42, which I don't know what city that is. One's in yeah, looks like Illinois. So I'm not sure exactly what city that is, but anyways, same city. So if we look at this, you can see that we have Benguela Manor, and Benguela Manor matches up with itself. Benguela Manor matches up with Vilnius Manor, 43 Vilnius Manor. And then you can see kind of like the inverse of that, where Vilnius Manor ties up with Benguela Manor, and then Vilnius Manor up with itself. So now we obviously only want to see like the combinations that make sense. Like you can't Secret Santa gift yourself, obviously. So we just need to filter those out. Now we have a couple different options here. We could use a where clause, or we can use an addition to our join. And that's what I'm going to do. So instead of using the where clause, I'm just going to add a thing here, and function is largely the same. The only thing that I would say is I like to, like if it's fundamentally part of the join, I like to keep it in the join. So that way you can use the where clause for other stuff, and it just keeps it a little cleaner, but that's just kind of preference. So I'm going to say, hey, we just want to make sure that A1 dot city ID does not equal A2 dot city ID, right? Because we want to exclude instances like this where 543 pairs up with 543. So let's run this. And you'll notice, and not city ID, sorry. We want it where the address IDs don't, because that would defeat the whole purpose. We don't want the same addresses tied up. So boom, there we go. And you'll notice that this list got a lot smaller because all of a sudden we only have the addresses that actually have the option of doing Secret Santa. So now you'll see that, Benguela Manor ties up with Vilnius Manor. But you'll also notice that we get two options, one where it equals the other, and then just the inverse. And that's okay. We're going to leave it just like that. Basically we want to see every combination. Now I'm sure we could find a way to essentially get rid of that, but we're not going to worry about it right now. So anyways, that's the answer to this one. It is called a self join. And whenever we do self join, it requires an alias, obviously, because you're using the same table. Does that make sense? This one's kind of a weird one, but does that make sense to everybody?
So what other situations might you use this?
That's a great question. That's a really good question. So, so a great example is, let's say that we wanted to see every every customer that's in the same household. Now I don't know if like that data really works, so to speak. To kind of like say like, hey, I don't know if the Sequila data has anyone that lives in the same address, but that would be one example. But one of the most real life examples that I see are when people create user tables. So, let's say that we were going to create a user table, and we had things like, I'm going to call it system user. We have like a user ID, right, which is our primary key. And then let's say we also have a username, which is a varchar. No. And then let's say that it is created by, because we want to see, we want to know like who created our stuff, right? So whenever someone creates a new user, it logs who it was created by. And then we're also going to see who it was created at. Oh, carried away the columns. There we go. So let's say we had a table like this, right? Where we created this table. We have the system user table. It's something like this, right? Now I didn't define haven't defined the actual foreign key yet because technically it's impossible because we can't create something from nothing. But let's say I'm the first one in the system, right? I'm the admin. So I'm actually going to insert into system user. And we're going to say, we're going to insert into username. And I guess I really can't do this, can I? Yeah, I can. Username created by user ID. And the rest are defaults. We're just going to leave it just like that. And I'm going to insert a user called admin and just put a 1 in there. And the reason why I put the 1 is because someone had to create the first user. And in this case, it was, I guess we already have it up here. It was itself. It was created by user ID admin. But let's say that I also wanted to create another person. Like let's just use myself here, for example. So I'm just going to throw in another user here. Now, if I do this, you can see that now I have a couple users. The first 2 were created by that, but now let's say I want to create someone else, like let's say Bilbo Baggins, but let's say that I created him, right? So we don't use the admin for everything like we shouldn't. So now we have 3 users, admin, myself, and a Bilbo Baggins. So now if we wanted to see who created that user, and let's give these different aliases. I'm going to call this the OG because that's like the actual data. And then we're going to call this DDY for daddy, whoever created it, right? Like that's what we're going to call it. So OG dot created by user ID is equal to DDY dot user ID. And see, this is another instance where to add context, the column names might not match up exactly. But you can see here that like, okay, we have our OGs, which is the list we're looking at. But what we want to do is we want to add on who created them. So then let's take a look. Let's do our OG.user ID. Let's add in our OG.username. And then we're going to add in our other information, but we're going to give these, again, column aliases. So I'm going to say, hey, this is the creator ID. So if we were going to audit our data, now we could say, okay, look, here's all of our users and who created them, right? So like if we were auditing security, like, or if we see some Bilbo Baggins, right? We know he's not real. Like we could say, okay, which one of you hooligans that work at this video store, created Bilbo Baggins as a user, right? And then that way you could see, because you would build that kind of like into your application. So then they could say like, oh, Tanner made him. Let's get after him. That makes sense?
Yeah, very interesting use case. But yeah.
Yeah. It actually happens a lot. And I mean, there's other kind of edge cases where, sometimes you'll use it to like, just create multiple versions of the same thing for various reasons. Like I said, you end up doing it more than what you think. They're just very specific, like in that case, or just situational. Anyways, let me drop this table. So don't clutter. Okay. Good questions. All right. And then in the chat, Rachel asks, what does blob? I'm guessing you're wondering what a blob is. A blob is a binary large object. And it's a way that you can store bigger things. Like, so we store like names and stuff like that are technically like short, but binary large objects allow you to store bigger things like documents or pictures or just a bigger chunk of text. So that's why it's binary. It stores it in binary so you can kind of keep it and turn it back into whatever you want when you pull it out the other side. But binary large object, we probably won't use those at all in this class because they're pretty specific. All right. Cool. So question 4, it says just find all the shows that starred Joe Swank that have a specific length. This is very similar to question number 2. So I'm not going to do this one because it's almost the same thing. Figure I need to leave something for you guys to do. And then question 5 says, write a query that shows how many rentals are associated with each of the 2 staff members. So basically it wants you to find the rentals and kind of find the staff members. Now we're going to kind of go through one similar to this. I'm going to leave this one purely because, we haven't covered aggregations yet. I believe we do that next week, maybe. But we've kind of talked about aggregations in the past, but not in depth. So anyways, we'll kind of show a little bit of this one, just so we can kind of get a feel for it with this count function. So we want to see how many rentals each sales associate has had. So, maybe one's been there longer, maybe they hired them at the same time. And we're like, hey, is there one person that does better than the other? Maybe we're going to do a bonus and we say, hey, if one is clearly better than the other, we'll give one the bonus. But if they're the same, we'll split the bonus or something like that. So let's do number 5 here. Question 5. So again, let's start by getting our sales associates. So if I look at my table list, you'll notice that there's this staff table. So there we go. That's exactly what we're looking for. And so I'm going to do this. I'm just going to use staff ID instead of their actual name. And then that way you guys can polish off 5, but you'll have the foundation. So I'm going to call this, let's just call it S. And then I'm going to do a join. Now, one of the things that I'm going to do different in this one is kind of showcase how, there could be some different scenarios. So far, if you look, we've used all these inner joins. And again, I don't know if you guys have seen the announcement, but one of my favorite resources, you can just Google SQL joins on Google Images and it'll pull up these, right? And this is by far my probably favorite, my favorite kind of resource for this. That's a terrible photo. It's here somewhere. There it is. So this is my favorite resource to kind of teach it. So even like mentally, I remember when I was learning these, I would actually, when I was taking my certifications, I remember on a little whiteboard, just drawing out the joins. And sometimes I still do that if it gets really complicated, but I just do the joins. I just draw it out just like this, Venn diagrams. So each one of these circles, just like we all know what a Venn diagram is a table. And different types of joins return different types of stuff on the other side. So for example, we've been doing this inner join. It's in the middle because it's kind of like I wouldn't call it the default, but pretty close. where it just returns the matches, right? So what I'm going to do real quick, just to kind of give us some ground to stand on here, is I'm actually going to insert myself into the staff here at this video store. So I'm going to say insert into staff. Let's put in the first name, last name, address ID, picture we're going to ignore, email we need, store ID, active, username, password, and yeah, let's just leave it at that. Let's do values. So here we go. So myself, we're just gonna say I live at address 1. Say fake employee at gmail.com. I'm at store 1. I'm active. Just use my name as my username here. And then for password, we're just going to kind of throw some in there. Normally that stores the hash, which is what it looks like there. So let's see if this works. Boom, there we go. So now I'm a staff member, right? Just got added. So let's start off this exercise just doing it how we always did. So we can see our staff here, and if we take a look at rental, okay, you'll notice that for every rental we have this staff ID. So perfect, nice and easy connection here. So I'm going to select everything from staff S, inner join, just like I said, just like we did it before. We're going to inner join rental R. And again, we're just going to go from staff ID to staff ID between the two tables. Now, if I run this, you'll notice that we get a bunch of duplicate data. And again, like I said, sometimes we want that, sometimes we don't. So that's why it's important to understand your data. In this case, one staff member can have many rentals, and that's what we see, right? We see Mike Hillier many times because he has many rentals. Well, we see him once just duplicated for every unique rental over here. All right, so we can see the rental IDs keep going up and up. So what we want to do now is take these rows and we want to scrunch them down because we just want to see it aggregated, right? Like we want to see the count of rentals, not necessarily like all the raw data. And to me, that's like a distinct difference. There's raw data and then there's aggregated reports. And to me, that's the difference. Like, okay, we generated this raw data, which is great to build reports off of, but we can also build the report itself. So what we're going to do is we're going to get the staff ID, right? We're going to get the staff ID. But then what we want to do is we want to get how many rentals they have. And this is the part that you haven't learned yet, but we're going to kind of dig in here just for a second. So we want to count all the rentals. And what can we count that's unique so we don't duplicate? Well, rental ID, the primary key. So whenever you want to count specific things, we can count the primary key, or we can say, hey, I want to count distinct rental ID, which I do it always as a fail safe, but it is overkill. And I'm going to say as rentals. So then we can get as many rentals as we want. Now I'm going to run this and it's going to throw an error and it'll say, hey, in an aggregated query, you have to group this. So just like we talked about, we kind of want to take our many records and squish them down, but we have to kind of tell the database what we want to squish those down based on. Like what's going to remain constant and what are we squishing? Well, we want the person's name and the staff stuff to remain the same, but we want everything else to be aggregated or to basically turn into one row. So that's what we do. So we add this group by clause and we say we want to group by s.staff ID. Now, as a general rule, it's basically as long as you put your aggregation at the end, it's basically whatever comes before the aggregation. Put it in the group by clause, you're good. So boom, there we go. Now, quick quiz question. Can anyone tell me why I'm not in here? See, we see the two people and the rentals, but we only see the 2. Where am I? So I was staff ID 3. Oh, go
Yeah,
ahead.
but you don't have any sales yet.
Yep, perfect. Yep. So I don't have any sales yet. And this is where those different SQL joins come into play. So we've been using this inner join, but depending on what we might want, let's say that, hey, we don't want to lose sight of this employee who's been sitting in the back playing this Nintendo Switch, right? And locking the door. We want to know that. So maybe what we want is we want all the employees, whether or not they've gotten a sale. So in this case, we want to do a left join. So there's a good time to talk about all the joins. So we have our inner join, which is just the middle. It's the inner, what's matched between the two, and it will actually exclude everything else. There's a left join, which includes everything from the left side of the query. And in this case, the left side is whichever table comes first. And, it includes that whether or not it has a match. The complete opposite, and they do the same thing. It's just completely order of operation is the right join, which means, hey, we would want every rental, whether or not it was done by a salesperson, which in this case doesn't make sense, but they basically have the two so you can really quickly just swap them without changing the order of operation, the order in which you list them in the front clause. Because that's the only difference. The left and right is purely just whichever one you list in the from clause first. Then they have these, which are called left outer and right outer. And basically the only difference is they're the outer side, and they're actually not their own like join, so to speak. You just filter out the ones that are in the middle. So you'll see like where the key is null, right? So for example, let's first fix ours. So we want me to be included here. All we have to do is change that to a left join. Now, if we run this, now you'll see me, staff ID 3 with 0 rentals. Now, let's say we just wanted to know, hey, which staff don't have rentals? So all we would have to do is say where r.staff ID, the key, what they mean by key is the key that you joined on, is null. Let's put it up here where it's supposed to be. And there we go. So now you'll see that we eliminate it because since I don't have any rentals, r.staff ID is null. So that is our outer join, our left outer join, which just incorporates a where clause. Now there's also this full join or the full outer join where you can kind of basically get everything, which you just use full join. And then you can also kind of just say, hey, I want everything that's not in them. So some good examples, like let's say that you were doing some research for BYU, right? And you said, hey, I want to know which students took CIT225 and CIT130, right? You could do that. That would be the inner join. Now, let's say that we said, hey, we want to see the students who took CIT225 and CIT230, but not the ones that took both. Or, we have our 2 class lists. We want to see who didn't take both. And that would be, this one down here. So anyways, lots of different use cases for them. You have to kind of think about it. I'll be honest, the left join is kind of my go-to because I like to kind of see as I go along what doesn't exist. But if you only care about what matches, then you could use the inner join. So I use left join a ton. I use inner join probably second most, and then cross join probably third. And the cross join is the last one we talked about. That's that Cartesian product that just multiplies, and you can do it like this, where we say, hey, give me everything where staff cross join store. And this one doesn't take an on clause, but it duplicates everything. So it just takes staff times store, and it's called a cross join, generates that Cartesian product. This is just the ANSI 92 version of this, like what we did earlier, where we say select everything from staff, comma, store. So these are the exact same two queries. The only difference is this one is ANSI 89. So this will give us the same result as that. So anyways, those are our joins. This is step 4. But let's get rid of this. And there we go. So that one would show basically what you want. Now, obviously you won't have a 3. In fact, let's get rid of mine. Delete from staff, where staff ID is equal to 3. And there we go. So on that last step, if, I would say a left join is probably what we want. In fact, on all these other ones, most of these, you could probably almost say that left join is what you want, but just depends on the situation. Like, for example, if we're doing a mailer, right, on this step 1, if we're doing a mailer, I don't think we have any in the database, but, there would be no sense in generating a record for somebody if they don't have an address. Right. But one might also argue that, hey, maybe we want to see that person who doesn't have an address, right? And in this case, we would want to do left joins across both of these, because remember, like if you did an inner join on city, it would be the same result because this already acts as one. So if you did an inner join on city, if they didn't have an address, they couldn't have a city, and so they'd be excluded. So if you wanted to see all the ones, whether or not they had an address, you'd want to use left joins throughout the query. All right. Any questions? Okay. So Noah says, if you just type join instead of referencing the specific type of join, does MySQL assume it's a left join by default? That is a great question. Actually, it's a fantastic question. And the answer is that by default, I believe it assumes let's just try it. Let's just do it on this one. Now, let's put myself back here in the staff. So yeah, it looks like it assumes an inner join by default in MySQL. And just as a way of going, you may see it in the book a lot. I would say, is someone who works in the field and sees a lot of SQL code, I would always use the specific name, inner, left, whichever one you need to use. I would specifically do that. That's kind of the new standard. So I would just kind of get in the habit of that. I would kind of steer clear of the plain Jane join or these old comma things and stuff like that. And I think, as far as functionality, it doesn't matter, but it's just one of the reasons why it is the new standard is because to the reader, it's very explicit and you can just see it, instantly. Mentally, it helps you kind of build this picture. Like even me, I didn't know the answer to that question, to be honest, like what it did by default. And so anyways, great. Well, appreciate you guys' questions. Any other questions before we jump off? Yeah, no, thank you guys for being here. Appreciate you. If you have any questions along the way, feel free to reach out. Otherwise, have a great week, and we'll see you next time.